Hello students, welcome to this lecture One Number Systems. So in this lecture we will cover NCERT Exemplar problem One Number Systems. Okay, so let us start. So here in question number 1, here we have this question: every rational number is what? Okay, so here we have given 4 options. Among these 4 options, which option will correct, that we will have to find here. So let us see the answer. So here we know that every real number is either an irrational number or rational number. Therefore, every rational number is a real number. Okay, so the option number C is a correct answer. So every rational number is a real number. Now let us move to the next problem. So in next problem, here we have between two rational number. In option A, we have there is no rational number. In option B, we have there is exactly one rational number. Okay, and in option C, we have there are infinitely many rational number. Okay, and in option D, we have there are only rational number and no irrational number. So let us check which option will correct. So we have studied in our previous lecture. In fact, between two rational number, there are infinitely many rational number. Okay, so between two rational number, there are infinitely many rational numbers. So here the correct answer is option number C. Now let us move to the next problem. So in next problem, here we have decimal representation of a rational number cannot be terminating, non-terminating, non-terminating, repeating, non-terminating, non-repeating. Okay, so which option will correct? So we know that the decimal representation of a rational number cannot be non-terminating, non-repeating. Okay, that means decimal representation of a rational number can be non-terminating and repeating. Okay, and terminating decimal expansion. Okay, so we know that the decimal representation of a rational number cannot be terminating and non-repeating. Okay, so here hence the correct option is option number D. Okay, so now let us move to the next problem. So in next problem, here we have the product of any two irrational number is what? So in option A, we have always an irrational number. In option B, we have always a rational number. In option C, we have always an integer, and in option D, we have sometimes rationals and sometimes irrationals. Okay, so let us check which option will correct. Okay, so first of all, here we know that the product of any two irrational number is sometimes rationals and sometimes irrationals. Okay, hence here the correct option is option number D. So here the correct option is option number D. So now let us move to the next problem. So in next problem, here we have the decimal expansion of the number root 2 is what? So here root 2 is which type of numbers? Root 2 is an irrational number. Okay, so here you can say we know that the decimal expansion of root 2 is 1.41421 and ... which is actually non-terminating and non-recurring decimal expansion. Okay, so hence the correct option is option number B. Option number B. Okay, so 1.41421 and ... Okay, and now let us move to the next problem. In next problem, here which of the following is irrational? So in first one we have square root of 4 by 9. In second one we have square root of 12 by square root of 3, and in C we have root 7, and in D we have root over 81. Okay, so among these 4 options, which option will correct, that we will have to find here. So let us check. Here first option, here we have square root of 4 by 9, that is actually equal to 2 by 3, which is a rational number. Okay, and in option D we have root 12 by root 3, and root 12 can be written as root over 4 into 3 divided by root 3, and this is equal to 2 times root 3 by root 3, and this is equal to 2, which is a rational number also. Okay, and root 7, this is irrational number, and here root 81, this is equal to root over 9 square, and this is equal to 9, which is a rational number. Okay, so here hence the correct option is option number C. So now let us move to the next problem. So in next problem here we have asked which of the following is irrational number. Okay, so in option A we have 0.14, in option B we have 0.1416 bar, and in option C we have 0.1416 full bar, and in option D we have 0.401400140014 Okay, so let us check which option will be correct. So here in option A we have 0.14. This is terminating decimal, hence it cannot be an irrational number. Okay, and in option B we have 0.1416 bar. This is a non-terminating but repeating decimal expansion. Okay, hence it cannot be irrational number. And in option C we have 0.1416 bar, and this is actually a non-terminating and recurring decimal. Okay, hence it cannot be an irrational number. Okay, and in option D we have 0.401400140014 this is non-terminating and non-recurring decimal. Okay, hence it is an irrational number. Hence the correct option is option number D. Okay, so now let us see question number 18. Question number 8. Okay, so here in this question we have a rational number between 1, 2 and 3 is what? So let us check which option will correct. So we know that root 2 is equal to 1.4142135 and ... and root 3 is equal to 1.7320500807 ... So here 5 is a rational number which lies between root 2 and root 3. Hence the correct option is option number C. So this is actually our correct answer. So now let us move to question number 9. So that the value of 1.999 ... in the form P over Q, where P and Q are integers and Q does not equal to 0 is what? Okay, so here we first let x is equal to 1.999 ... Okay, that is actually equal to 1.9 bar, and then if we multiply 10 in both sides, then we get 10x is equal to 19.999. Okay, and this is equal to actually 19.9 bar. And now subtracting this equation and this equation. Okay, subtracting equation 1 and 2, then we get 9x, this is equal to 18, and it implies x is equal to 18 by 9, that is equal to 2. Okay, so the value of x is equal to 2, so therefore the value of 1.999 ... in the form of P over Q is equal to actually 2. Okay, so hence the correct option is option number C. Okay, so now let us see next question. So in next question here we have 2 times root 3 plus root 3 is equal to what? Okay, so here 2 times root 3 plus root 3, that is actually equal to 3 times root 3. Okay, hence the correct option is option number C. And now let us see question number 11. So in question number 11 here we have root 10 times root 15 is equal to what? Okay, so we have to first of all simplify it. Okay, so if we simplify it, then we'll get root 10 into root 15, that is equal to root over 5 into 2 into 5 into 3, that is equal to 5 into root 6. Okay, hence here the correct option is option number B. And now let us see question number 12. So in question number 12, the number obtained 1 rationalizing the denominator of 1 by root 7 minus 2 is what? Okay, so you have studied how to rationalize a number. Okay, so here rationalizing the denominator as follows: 1 by root 7 minus 2, this is actually equal to 1 by root 7 minus 2 into root 7 plus 2 by root 7 plus 2. Okay, and this is equal to root 7 plus 2 divided by root 7 square minus 2 square, and this is equal to root 7 plus 2 divided by 7 minus 4, that is equal to root 7 plus 2 by 3. Okay, hence here the correct answer is option number A. And now let us move to the next problem. So in next problem here we have 1 by square root 9 minus square root 8 is equal to what? Okay, so we have given 4 options. So among these four options, which option will correct, that we'll have to find here. So let us check. So here 1 by square root of 9 minus square root of 8. Here first of all we rationalizing the denominator root 9 minus root 8. Okay, then we get this is equal to 1 by root 9 minus root 8 into root over 9 plus root 8 by root over 9 plus root over 8, and this is equal to root over 9 plus root over 8 divided by root over 9 square minus root over 8 square. Okay, so this is equal to root over 3 root over 3 square plus root over 2 cube divided by 9 minus 8, and this is equal to 3 plus 2 times root 2. Okay, hence the correct option is option number B. So now let us move to the next problem. So in next problem here we need to find the value of 7 by 3 times root 3 minus 2 times root 2. Okay, so after rationalizing the denominator, so we get the denominator as 7 by 3 times root 3 minus 2 times root 2, that is equal to 7 by 3 times root 3 minus 2 times root 2 into 3 times root 3 plus 2 times root 2 divided by 3 times root 3 plus 2 times root 2. Okay, and this is equal to 7 times 3 times root 3 plus 2 times root 2 divided by 3 times root 3 square minus 2 times root 2 square, and this is equal to 7 times 3 times root 3 plus 2 times root 2 divided by 27 minus 8. Okay, and this is equal to 7 times 3 times root 3 plus 2 times root 2 divided by 19. Hence the correct option is option number B. Okay, so now let us move to the next problem. Here in next problem here we have to find the value of root 32 by root 32 plus root over 48 by root over 8 plus root over 12 is equal to what? So let us find the value. So here root 32 plus root 48, that is equal to actually root over 16 into 2 plus root over 16 into 3. Okay, and in denominator root over 8 plus root over 12, that is equal to root over 4 into 2 plus root over 4 into 3. Okay, so this is equal to root over 16 into 2 plus root over 16 into 3 divided by root over 4 into 2 plus root over 4 into 3, and this is equal to 4 times root 2 plus 4 times root 3 divided by 2 times root 2 plus 2 times root 3, and this is equal to 4 times root 2 plus root 3 divided by 2 times root 2 plus root 3, that is equal to 2. Okay, so hence the correct option is option number B. And now let us move to the next problem. So in next problem here, if root 2 is 1.4142, then square root of root 2 minus 1 by root 2 plus 1 is equal to what? Okay, so let us check. So here root over root 2 minus 1 by root 2 plus 1, this is equal to square root of root 2 minus 1 by root 2 plus 1 into root 2 minus 1 by root 2 minus 1. Okay, and this is equal to square root of root 2 minus 1 whole square by root 2 square minus 1 square, and this is equal to root over root 2 minus 1 whole square divided by 2 minus 1, and this is equal to square root of root 2 minus 1 whole square by 1, and this is equal to root 2 minus 1, and we know the value of root 2 is equal to 1.41 for 1.4142 ... Okay, so 1.4142 minus 1, this is equal to 0.4142 ... Hence the correct option is option number, this is actually equals to 2 to the power 1 by 6. Okay, so correct option is option number C. And now let us move to next problem. So in next problem here, the product root cube root 2 into 4th root 2 into 12 root 32 equals to what? Okay, so let us find. So here cube root 2 plus 4th root 2 plus cube root 2 into 4th root 2 into 12 root 32, that is equal to 2 to the power 1 by 2 into 2 to the power 1 by 4 into 2 to the power 5 to the power 1 by 12, and this is equal to 2 to the power 1 by 3 2 to the power 1 by 2 into 2 to the power 1 by 4 into 2 to the power 5 by 12, and this is equal to actually or you can use now exponent formula. Okay, then you will get the answer. Okay, so let us find remaining portion. Now let us move to next problem. So next problem, you have to find the value of 4th root of 81 to the power minus 2 is what? Okay, so fourth root of 81 to the power minus 2, this is actually equal to fourth root of 1 by 81 square, and this is equal to 1 by 81 square whole square into 1 by 4, and this is equal to 1 by 81 to the power 1 by 2, and this is equal to 1 by 9. Okay, so correct option is option number C. Okay, and then let us move to next problem. In next problem, here we have to find the value of 256 to the power 0.16 into 256 to the power 0.09. Okay, so here 256 to the power 0.16 into 256 to the power 0.09, that is equal to 256 to the power 0.16 plus 0.09. Okay, and this is equal to 256 to the power 0.25, and this is equal to 256 to the power 1 by 4, and this is equal to 4 to the power 1 by 4, that is equal to 4 to the power 4 into 1 by 4, that is equal to 4. Okay, so hence the correct option is option number A. Now let us move to next problem. So in next problem, which of the following is equal to x? Okay, so let us find. So here in option A we have x to the power 12 by 7 minus x to the power 5 by 7, that does not equal to x. Okay, and in option B we have 12 root of x to the power 4 to the power 1 by 3, that is equal to 12 root of x to the power 4 by 3, and this is equal to x to the power 4 by 3 into 1 by 12, and this is equal to x to the power 1 by 9, that does not equal to x. And in option C we have square root of x cubed to the power 2 by 3, that is equal to x to the power 3 by 2 into 2 by 3, that is equal to x. Okay, that is equal to x, and here correct option is option number C. And now in option D we have x to the power 12 by 7 into x to the power 7 by 12, that is equal to x to the power 12 by 7 plus 7 by 12, that is equal to x to the power 193 divided by 84, that does not equal to x. Okay, hence the correct option is option number C. Now let us move to next section. So in next section here we will discuss short answer question with reasoning. Okay, so let x and y be rationals and irrational number respectively. Then is x plus y necessarily an irrational number? Okay, and give an example in support of your answer. So let us see answer. This is true because x plus y is necessary an irrational number. We can let x is equal to 6 and y is equal to root 3. Then now x plus y, this is equal to 6 plus root 3, and this is equal to 6 plus 1.732 ... which is non-terminating and non-repeating. So therefore x plus y is an irrational number. And now let us move to next problem. So in next problem here we let x be rational number and y be irrational number. So then it asks, is x y necessarily irrational, and justify your answer by an example. Okay, so the answer is it is not necessarily. So here we let x equal to 0 is rational and y is equal to root 3 is irrational number. Then x y, this is equal to 0 times root 3, that is equal to 0, which is not an irrational number. Okay, so if let x be rational and y be irrational number, then it is not necessary x y is irrational. Okay, so now let us move to next question. So in next question here state whether the following statement are false, true or false. Okay, and justify your answer. So here in first one we have root 2 by 3 is a rational number. Okay, and in second one here we have there are infinitely many integers between any two integers, and in third one we have number of rational number between 15 and 18 is finite, and there are in fourth one we have there are numbers which cannot be written in the form p over q, where q does not equal to 0 and pq both are integers. And fifth one we have the square of an irrational number is always rational number. Okay, and in sixth one we have root 12 by root 3 is not a rational number, as root 12 and root 3 are not integers. Okay, and in sixth seven one we have root 15 by root 3 is written in the form p over q, and so it is a rational number. So let us check whether the following statement are true or false. So in first statement, root 2 by 3 is actually irrational number. Okay, so this statement is a false statement, and we know that in between two integers there are infinitely many integer. Okay, so between two integers, so there are infinitely many integers between any two integers. No, this is not true. Okay, so actually between two integers there are no integers. Okay, and third statement, number of rational number between 15 and 18 is finite. This is false, because between 15 and 18 there are infinitely many rational number. Okay, and there are numbers which cannot be written on the form p by q, where both are pure integers. Okay, yes, there are numbers which cannot be written in the form p over q, where q does not equal to 0 and p, q both are integer. These numbers are called irrational number. Okay, and fifth one, the square of an irrational number is always rational number. No, this is not always rational number. You can take example 2 plus root 3 whole square. That is not a rational number. Okay, so then root 12 by root 3, this is not a rational number. This system is also false. Here root 12 can be written root 3 into root 4 divided by root 3, that is equal to 2. Okay, so this is rational number. Okay, root 15 by root 3, this is actually root 3 into root 5 by root 3, that is equal to root 5, and this is irrational number. So root 15 by root 3 it cannot be written in the form p over q. Okay, so now let us move to next problem. So in next problem, here we have to classify the following numbers are rationals and rationals over irrationals with justification. So square root of 196, these are given to us. So now let us check whether the following numbers are rational number or irrational number. So here square root of 196, that is equal to square root of 14 square, this is equal to 14, which is a rational number. Okay, and second one, 3 times root over 18, that is equal to 9 times root 2, and which is an irrational numbers. Okay, and root over 9 by 27, that is equal to 1 by root 3, and which is an irrational number. And root over 28 by root over 343, that is equal to root over 4 by root over 49, that is equal to 2 by 7, and which is a rational number. And minus root over 0.4, this is equal to minus 2 by root over 10, and this is actually an irrational number. Okay, and 6 root over 12 by root over 275, this is equal to root over 4 by 25, and this is equal to 2 by 5, which is a rational number. And 0.5918 is terminating decimal, so therefore it is a rational number. 1 plus 5 root 5 minus 4 plus root 5, this is equal to minus 3, which is a rational number. Okay, and 10.124 is a decimal expansion which is non-terminating but recurring, hence it is a rational number. Okay, and then 1.010010001 is a decimal expansion which is non-terminating but recurring, hence it is a rational numbers. Now let us move to next section. So here we'll discuss short answer questions. Okay, so find which of the variables x, y, z and u represent rational number and which irrational number. Okay, so here in first one we have x square is equal to 5. Okay, and second one we have y square is equal to 9, and third one we have z is equal to 0.04, and fourth one we have u square is equal to 17 by 4. Okay, so let us see answer. So x square is equal to 5. This is implies x is equal to plus minus root over 5, which is an irrational number. Okay, and y square is equal to 9. This implies y is equal to root over 9, and this implies y is equal to plus minus 3, which is a rational number. And z square is equal to 0.04. It implies z is equal to plus minus square root of 0.04, and it implies z equal to 0 plus minus 0.2. Okay, so 0.02. So this is also rational number. And u square is equal to 17 by 4, and it implies u is equal to plus minus 17 by 4. Okay, and this implies u is equal to plus minus 17 by 2, which where root over 17 is not integer. This is irrational number, so therefore this is an irrational number. Okay, then let us move to next problem. So in next problem, find 3 rational numbers between -1 and -2, 0.1 and 0.11, 5 by 7 and 6.7, and 1 by 4 and 1 by 5. Okay, so let us find. So -1.1, -1, 2, and -1, 3 are, and -1.1, -1.2, and -1.3 are 3 rational numbers which are lying between -1 and -2. Okay, and 0.101, 0.102, 0.103 are three Rason's number which are lying between 0.1 and 0.11. Okay, and 5 by 7, this can be written 5 by 7 into 10 by 10, that is equal to 50 by 70, and 6 by 7, this is equal to 6 by 7 into 10 by 10, that is equal to 60 by 70. So here 51 by 70, 52 by 70, 53 by 70 are three Rason's number lying between 50 by 70 and 60 by 70. Okay, so it means that lying between 5 by 7 and 6 by 7. Okay, and in the fourth one we have 1 by 4. We have to find the Rason's number between 1 by 4 and 1 by 5. So 1 by 4 can be written as 1 by 4 into 20 by 20, that is equal to 20 by 80, and 1 by 5 can be written as 1 by 5 into 16 by 16, that is equal to 16 by 80. Okay, so now the Rason's number between these two numbers basically 17 by 80, 18 by 80, 19 by 80. Okay, these are Rason's number between 1 by 4 and 1 by 5. So this is all about this lecture. Thank you very much to all of you.